Hey, this is Mr. Ward, and this is a video key for Do Now 21.3, week 21, day 3 for geometry. And here's the key. So first of all, please do check to make sure your current work is shared with me. And hopefully it is, but check if it's not. And there are a few of you whose work is not shared with me. So please do check that. You will need, once again, the definition of the foot of a line. The definition of foot of a line is the point of intersection of a line and a plane is called the foot of the line. So based on this, the definition above, name the foot of the line TC with respect to plane R. So let's find plane R. That's plane S, that's plane R. So let's find line TC. This is line TC. And where is its foot with respect to plane R? This is plane R, so its foot is C. That is where it intersects with plane R. So point C is the foot. Okay, now I'm reminding you of the postulates and theorems I shared with you last class. 3 non-collinear points determine a line. Basically, make a triangle that, that produces what you need to determine a plane. And theorem 37, a line and a point not on the plane determine a line. And 2 intersecting lines determine a plane. And 2 parallel lines determine a plane. So we want to figure out which plane, so points A, B, and E determine which plane. So let's find A, B, and E. They determine this plane here, which is plane S. Plane S. Now lines A, B, and ED, A, B, and ED, which one do they determine? Well, they also determine plane S. They are intersecting lines on plane S. So plane S, again, is determined. Now do lines DC and ED determine a plane? So here's DC and here's ED. In fact, they do determine a plane. It's just not labeled here. They determine a plane because they're intersecting lines. Yes, because they are intersecting lines. And you might have gone back up to review the theorems and the postulates. So here we go. Theorem 38, 2 intersecting lines determine a plane. And DC and ED intersect at D, so they will determine a plane. Now let's name 4 non-collinear points. And there's a variety of things that you might choose. But if I chose A, E, and B, and then I chose C, they would be non-coplanar, I mean. I could also have chosen D, B, E, and T. Those are non-coplanar. So you'll find 3 that are coplanar, and then there will be a 4th one that is not. So answers will vary there. But basically, you could also have chosen C, D, and E, and A if you wanted to use one of the planes that's not formally labeled, since C, D, and E determine a plane, and B is not on that plane, and A is not on that plane. C, D, and T also determine a plane, so C, D, T, and A would work as well. So you have a few options. I'm going to just say answers will vary. Pick 3 coplanar and 1 non-coplanar point, and you are good. Okay. Now we do have a proof here. So propose a strategy for proving this conclusion. If you can prove it, do so. So we know that points A, P, and B, so A, P, and B, lie on plane M as shown. And we know that line CP is perpendicular to AP, and it's also perpendicular to PB. Okay, and we know that PA and PB are congruent. And we're asked to prove, is CA and CB, are they congruent? Well, so here's the neat thing. If we can prove that this triangle is congruent to this triangle, then we'll be able to prove that. We also might be able to prove that, well, let's get there. So let's see. We've got these 3 points are on the plane. We know CP is perpendicular to AP. So let's label what that means. That means that that is a right angle. We also know that it is perpendicular to PB. So then that is also a right angle. All right, now we have an angle. We know that PB and PA are congruent because it told us that's a given. So there we have those two. And that's the only information that we're really told formally. However, we can also add that CP is itself. And once I have that, I have a side angle side for this triangle and a side angle side for this triangle. So now I can prove that CA and CB are congruent by Kappa-Kadika. So let's go through the steps. So after the givens, then we can say that CP, so angle CPA is right, okay, and so is angle CPB by definition of perpendicular. Okay, and that's because CP is perpendicular to both of those. Now we can also say that CP is congruent to CP by reflexive. And then we can say triangle CAP is congruent to triangle CBP by side angle side. Then finally, we are at CA is congruent to CB by corresponding parts of congruent triangles are congruent. And we are done with that. So it's actually a surprisingly simple proof once you get over the fact that it's an unusual three-dimensional situation. Once we've done all that, we could also prove that CAB is an isosceles triangle if we wanted. So that's kind of neat. And we could prove, there's CBP is congruent to CAP by Kappa-Kadika and so forth. So this four-pointed thing is kind of a folded isosceles triangle, making a quadrilateral that is three-dimensional because it's folded. Those are other things just to note of interest. But the big thing is we just needed to work out that these two angles were right, and therefore they are congruent. You might want to say that as well. I could probably say CPA is congruent to angle CPB because right angles are congruent. That's theorem 1 from the book. And then, of course, we can prove that CP is itself. We've been given AP and BP, so we have a side angle side, and that will lead us to Kappa-Kadika for CA and CB. I hope that's helpful.